Daniel Kwan and this is KTH Math Tutoring Club. Today, we're going to talk about 2016 AP Calculus BC free response question number 6 Part B. Part B says, the Taylor series for f about x equal to 1 has radius of convergence 2. Find the interval of convergence. Show the work that leads to your answer. So first of all, before we begin, this is the equation. Oh, right, better arrow, there you go. This is the equation that we got from Part A. And thankfully, the problem gives us the radius of convergence 2. If they didn't, we had to use the equation from Part A, exactly this part, and use the ratio test, which I wrote here just in case, to solve this problem unknowingly. Thank you, College Board. So, to solve this problem, there are 2 steps to do. So first step is finding the interval. This is not the interval. What I'm saying is like a rough draft, not the final answer, but simple interval, you'll see. And second part is checking the endpoints. Because the problem says Taylor series for f about x equals to 1, the center will be x equals to 1. And has a radius of convergence of 2. So radius of convergence of 2. The way to find the interval is by adding and subtracting the radius to the center. So it will be 1 plus minus 2, which is negative 1 x 3. So this is the first step, but we're not done. The reason why we have to do the second part, which is checking the endpoint, is because we have to know if the x is equal to or just greater than. I'm not sure if I worded that right, but still, I know you understood. So let's do part B. So in part 2, let's check the endpoints. So we got the interval, negative 1 is less, so x is greater than negative 1 and less than 3. And like I said, this is the rough draft. And to find the checkpoints and to check the endpoints, we have to use the formula that we got, or the equation that we solved from part A. So when x equals to negative 1, and we just need to plug the x value negative 1 into here and see if the series converges, then the x will include the points, and if it does not, then it will just not include the points. So we start with 1. So 1 and 1, so 1/2 and x minus 1. So minus 1 will be negative 2 and becomes minus 1. However, because of this sign, it will become plus 1. You can do this by plugging in, but after you calculate, this will come out. So as you can see, it's 1 plus 1 plus 1/2 plus 1/3 plus 1/4. This is harmonic series. As we learned about harmonic series, it always diverges, right? Diverges. So x negative 1 will not be included, so we just leave it here. Now let's check when x equals to 3. If you need help on why harmonic series diverges, you can go to another tutoring video in my YouTube channel or my website to check it out. So when x equals to 3, let's plug in 3. So when I plugged in 3 and calculated, I'll just do first few terms with you. It's 3. 3 minus 1 will be 2, and it doesn't change the sign. And 3 minus 1 will be again, oh, that's wrong, just ignore this. 3 minus 1 will be 2. 2 2 to the power of 2 will be 4, and this bottom one is 8, so it will become plus 1/2. And if I keep going, it will be minus 1/3 plus 1/4 dot dot dot. And this is alternating harmonic series. And again, so the -1 diverges. For alternating harmonic series, as its characteristic, it always converges. Thus, your answer will be like this. Because -1, when x equals to -1, it diverges, and when x equals to 3, it converges as harmonic series and alternating harmonic series. Your answer will be like this, and this will be your final answer for part B. Before we end this, to get the full credit, you must not only include this, but you have to also include all the works that I did, for example 1 plus 1 plus 1/2, those kind of things, to show that it is harmonic series and tell them it diverges, so they can know you know this concept. Thank you for watching, and be ready for the next video, which is part C and D at the same time. See you there. Thank you for watching.